Hello everyone and welcome to this week's lecture on ISM 415 Special Topics. Last week we looked at one step in our data science workflow, which is the exploratory data analysis. We saw how to import data in our Jupyter notebook, how to clean our data by searching for missing values and duplicate values and removing them. We saw how to convert some columns into their appropriate format. We also saw how to visualize our data and answer some business-driven questions. Now, this week and the next, we are going to be taking one more step in our data science workflow. In this case, we are going to be looking at applying techniques. Okay, so this week and the next, we are going to be focusing on machine learning. Right? At the end of these 2 weeks, you should be able to build your own machine learning algorithm to compete in our in-class hackathon, okay, which we are going to be doing soon. Right? So let's get started for this week. Now, our agenda for this week is going to be a straightforward one, okay? We try to understand first and foremost what machine learning is, what are the type of machine learning, and we also see the key elements in machine learning that we should take note of going forward, right? Then at the end of this lecture, we try to build a machine learning algorithm for a simple regression problem. So let's get started. What exactly is machine learning? Now, in a nutshell, machine learning is simply the ability of a machine to learn from data without being explicitly programmed by the data scientist. What we mean by that is, in machine learning, we simply apply our data into some particular algorithms which we are going to learn soon enough, okay? So the machine now, using the algorithm, learns the pattern from the data and is able to make decisions on his own, okay, like making predictions and all that based on what he has learned from the data. So let me give you a simple example. Now in this case, we are going to take the machine to be a child, okay? Let's say the child is in primary school or nursery school, who is just attending school for the first time. Now in the first class, the teacher decided to teach them about fish, okay? So the teacher drew a fish on the board and labeled the fish. Now the child becomes confused. Okay, how do I know that this is a fish? Now the teacher, explaining to the child, did this, okay? Said, okay, when you see something that looks like this, right, and the thing has fins, gills, and other features of a fish which you know, you have to identify that thing as a fish. So the child said, wow, that's interesting. So in test or in exam, the teacher will bring a rough sketch of a fish and say, okay, now based on what you've learned or based on what I've taught you about fish, label this fish. Now, using the experience and based on the knowledge the child gathered from the class on fish, the child is able to draw and label the fish regardless of the size and shape. So that is same thing with machine learning. We feed the machine with data. Now the machine in this case is the algorithm, okay? We feed it with the data. The machine identifies patterns in that data, okay, and is able to make decisions. Hope that makes sense. All right. Now, you might want to ask, what is the difference between machine learning, artificial intelligence, and deep learning, in case you've come across these few keywords. Now, let me explain them to you, okay, briefly. Now, artificial intelligence is simply the ability of a computer to mimic the human brain, okay? You know, our brain functions because of the neurons. So if you want to imitate the human brain, okay, or the human intelligence, okay, you want to assign it to a machine, that process is called artificial intelligence. Now, machine learning is like kind of a subset of artificial intelligence, which I already explained to you, where the machine tries to learn from the data so as to make decisions that normal human being can make on its own by learning patterns in the data. Okay, where deep learning is a subset of machine learning. Okay, now in deep learning we try to perform some complex tasks like working with multi-dimensional data. Okay, what I mean by that is in traditional machine learning algorithms we work with structured data or tabular data, like data in CSV form, which we looked at last week, or data in Excel form. But in deep learning we make use of the neural network. Okay, now the neural network is kind of the replica of the human brain. Okay, we use it to analyze multi-dimensional data like images, videos, audios. Okay, all right, so that is what deep learning is. So that's the major difference between them. Machine learning is a subset of AI and deep learning is a subset of machine learning. All right, now this is an image of a neuron which is in the brain. Okay, which is the brain. You have the axon, the synapse, the dendrite and stuff. Okay, now if you want to replicate this neuron, this human neuron, in a machine, okay, so this is how it looks. Now getting signals through the axon and transferring them in deep learning, we simply make use of these layers. We call them input layers. This is where we get the input variables in our features. Okay, then the hidden layers simply take the input variables or input layers, analyze them and produce an output layer. So we are going to look at this more closely as we proceed. So let's continue. Now let's look at the concept going forward. Okay, let's define some of the concepts we are going to be needing. Please take note of this. If possible, try to jot them down. Okay, so the first concept we are going to be looking at is features. Now features are simply independent variables. Okay, like I told you, the machine tries to understand patterns in your data so as to be able to make predictions. So the patterns here is simply to identify similarities between features. Features here is simply your independent variables, like, okay, the item you want to predict is dependent on some particular variables, which you are going to see as we proceed. The next one we are going to define is the label. The label is simply the dependent variable or what you want to predict. Okay, now the machine learns from the features so as to predict the labels. Does that make sense? Now the next concept we want to take note of going forward is the classifier. So this classifier, you can call it classifier and you can also call it regression depending on what you want to do. Okay, this classifier is simply your algorithm. Okay, what's your machine learning algorithm, okay, that learns from these features so as to predict your target variable. All right, so let me explain what I just said earlier. Now let's say we have a data set. Okay, in this case we have image data. Normally we are going to be working on structured data. This is multi-dimensional data. We're not going to be working with this. This can be analyzed using deep learning. Okay, we're just going to look at normal machine learning. Right now we have a data. We split the data into two. We call it training and testing set. So I'm going to explain that a bit in a few seconds, in a few minutes. Now the training data, we have bicycle, we have boat, we have car, and we have plane. And of course, you know, the machine doesn't understand images or what's it called, videos and stuff. So we have to convert them into numbers. Okay, so we convert this into vectors. So when these and so numbers are here, we classify them as bicycle. This is called the label, and this is called the features, which is the independent variable as we saw in the previous slide. Okay, so after converting this, we simply apply this data into our machine learning algorithm. So the machine learns from this pattern. Okay, when this is this is the outcome. So it learns from all these patterns. And for you to test the machine, just like the teacher is testing the child in exam or in tests, we give the machine a test data. Okay, so we encode the data into vectors and say, okay, based on these conditions here, make predictions for our label. What is going to be our label? Now when you feed this to the machine, it goes through the neural network and predicts, okay, this is a car. Okay, that's a simple flow chart for our machine learning. Okay, so let's look at key elements in machine learning. The first one is representation. Okay, every machine learning algorithm has to be represented, be it if you are working with decision trees, support vector machine, XGBoost, and all that. You have to represent them appropriately. So don't worry about this, we are going to see them as we proceed in this course. Then secondly, we need to find a way to evaluate our machine learning algorithms. For instance, if you are working on predicting numbers, okay, maybe doing regression problems, okay, you need to find the appropriate evaluation techniques for this. Okay, like I said previously, don't worry about this, we are going to see this in case the concepts are not clear to you. Okay, so like for instance in regression, we make use of the mean square error and other errors like the loss function and others. Okay, while in classification we make use of the accuracy, the recall, precision, and others. Now finally, we need to find a way to optimize our parameters. Okay, once again, don't worry about this, we are going to look at it, okay, when we start coding, so you better understand the concepts. Now, what are the type of machine learning? So in machine learning, we have three major types. We have the supervised machine learning, which is also called inductive learning. Okay, so in this supervised machine learning, the machine learns from features, independent variables, so as to predict a dependent variable. For instance, you want to determine who is going to be promoted based on the education and based on the sex or based on other parameters. Okay, this process is called supervised learning, where the machine learns from features so as to predict an outcome variable. Secondly, we have the unsupervised machine learning. Now in unsupervised machine learning, the machine learns on its own without having a label. For instance, you want to predict the house that has goats in it, for instance. Okay, so now there is no particular condition for houses having goats. Okay, so we apply unsupervised machine learning to cluster similarities. Okay, so a house that has goats has to exhibit so and so characteristics. It clusters them. So that's what we do in unsupervised machine learning. Then finally, we have the reinforcement learning. Okay, this is where the machine learns from its mistake. A typical example of reinforcement learning is the self-driving car. Okay, so when you train a model for a self-driving car, it makes mistakes and learns from that mistake so as not to repeat that same mistake next time. Okay, so for this course we are going to be focusing on supervised machine learning because it is the most matured and most studied type of machine learning algorithm. Okay, so let's look at the supervised machine learning and see how we can build our own supervised machine learning algorithm. So now in supervised machine learning algorithm, we feed our algorithm with raw data. Okay, now feeding it with the raw data, we have to split the data into two. Like I told you previously, we have the training and the test set. Okay, we apply the training set to the algorithm, it processes it and learns from it. Okay, then we test it using the test set so as to get our required output. For instance, if you want to predict whether a wine is going to be good, bad or normal, for instance, okay, that is dependent on different variables like the fixed acidity, the volatile acidity and others, okay, citric acid and stuff, right? So if you split the data into two, into training and test set, you train the machine with the other part, which is the training set. The machine learns the pattern. Okay, when fixed acidity is this, volatile acidity is this, and this is this, the wine should be good, right? When this and this is this, the wine should be bad. When this and this is this, the wine should be normal. Okay, that's basically what we do in supervised machine learning. The machine learns from independent variables so as to predict a dependent variable. So in supervised machine learning, we have two different models. We have the classification and the regression. Okay, in classification model, we try to predict a discrete level. For instance, the one I told you, trying to predict whether something is going to be good, bad or normal. Okay, that is specific. In that case, we are looking at classification. Then the second one is regression. Okay, so but first let's look at the type of classification model. We have the logistic regression, we have decision trees, we have random forest, we have support vector machine, XGBoost and many others. Okay, so this kind of model simply tries to predict a discrete variable. Okay, now the second type of supervised machine learning is the regression. So in regression, we try to predict a numeric or continuous output. For instance, you want to predict the price of a house in an area. Okay, you want to predict how much rainfall is going to fall tomorrow. You want to predict the price of stock and similar numeric output. So this falls under regression. So in regression, we have different models in regression, like the linear regression, we have the polynomial regression, we have the decision tree regression, we have the support vector regression, we have the XGBoost regression, okay, and many others. So let's briefly look at the other type of machine learnings. So the next one is the unsupervised machine learning, and like I told you, in unsupervised, the machine learns without a training and test data. Okay, you simply feed the machine the data, it clusters them, that is group them. Okay, this having so and so similar criteria, it will be grouped as so and so. Okay, let's take a look closely. So in unsupervised machine learning, we have clustering and association. So clustering is simply trying to identify patterns in uncategorized data. For instance, the example I gave you, trying to identify houses that has goods. Okay, now if you look at maybe using your village as a use case or my village as a use case, you identify some patterns or similarities between houses that has goods. Okay, maybe they have so and so, I don't know, you can figure it out, right? Okay, so that's what we basically do in unsupervised machine learning clustering, to be precise. Okay, then we have some clustering models like the k-means cluster, the k-nearest neighbor, and others. Okay, this is a typical example of unsupervised machine learning. We have data, okay, scattered all over the place, right? And we want to categorize them. Okay, we want to cluster them into data that has some similarities. Okay, so we make use of clustering. You can see the ones that has similarity are circled and stuff. So this is a typical example of clustering. So then the next one we look at is the association. This is similar to the clustering. Okay, we also try to identify relationships in variables here. Okay, now a brief recap. We looked at machine learning. We said machine learning is simply the ability of the machine to learn from data without being explicitly programmed by the data scientist. Okay, we saw that we have three different type of machine learning. We have the supervised machine learning, where the machine tries to learn from the independent variables so as to predict a dependent variable. Then we also looked at the unsupervised machine learning, where the machine tries to understand patterns. Okay, since there are no labels in the data, they try to understand patterns in the data given and cluster them appropriately. Then we also have the reinforcement learning, where the machine has to learn from its mistake. Okay, just like a typical example, which is the self-driving car. Now in this course we are going to be looking at just supervised learning. Okay, because it is the most studied and less complex of the three. Okay, and I told you previously that in supervised machine learning we have two major types. We have the classification and the regression. Okay, in classification we try to predict a discrete value, like trying to predict whether something is going to be good, bad, yes or no, this or this and stuff. Where in the regression we try to predict a numeric or continuous value. Okay, so this week we are going to be looking at simple linear regression. Then next week we'll look at classification before we go into our hackathon proper. So simple regression, this is the formula for it. Okay, this y here is y cap, some can call it y cap or y estimate and stuff. This is simply the variable we want to predict, and this variable is dependent on what is on your right hand side. So we have the a, which is the intercept, okay, estimated by the regression. We have the b, which is the coefficient of our independent variable. So let's go to our Jupyter notebook and see how to perform some simple linear regression. So let's take note of our time to make sure we don't spend so much time here. Okay, so let's take a look at the data we are going to be working with today. So like I said, we are going to be looking at simple linear regression. Okay, we are going to start from the basics, then we advance. Now we are going to be looking at a simple CSV file. Okay, So we want to look at how the years of experience is related to the salary. So what we try to do is we feed our machine with this data. Okay, first we have to split them into two. Okay, so the machine learns, okay, when the year of experience is this and the salary is this. Okay, it identifies the pattern in this data. So when we feed the machine with our test data, it is able to predict the salary, okay, the future salary of an employee. So let's get started with this. Okay, I've opened my Jupyter notebook. Okay, I've also renamed it machine learning and regression in parentheses. Okay, so similar pattern, you launch your Jupyter notebook, navigate to your working directory, and open your new notebook. So we are going to take the same step like we've always done, okay, by importing our libraries. That's the first step. Okay, step 1, import important libraries. Okay, so in today's lecture we are going to be looking at 3 major libraries, 2 of them which you already know. Okay, I'm going to introduce a new one, which is the NumPy. NumPy is a very powerful library, okay, in Python and in data science. It is used to convert data into arrays. Arrays, what we mean by arrays is to convert our data into matrix, okay, because our machine learning algorithm doesn't take in data frames. Okay, we have to convert them to arrays, and we can do that using the NumPy library. Okay, so the same way to import a library, we simply use import keyword. So we say import NumPy. So we can abbreviate it as NP. You can feel free, if you don't want to abbreviate it, you can just call it import NumPy. It doesn't matter. So the next library we are going to import is our pandas library, which is very important for our data manipulation. So simply say import pandas as PD. Then finally, the library we looked at last week, which is the matplotlib library, and of course you already know it is used for data visualization. Okay, so we simply import it. Import matplotlib.pyplot as PLT. Okay, because the name is long, I have to abbreviate them. So I'm going to run this and pause the video for it to launch, so don't waste so much time in this video. Okay, now after importing our library, the next thing we do is to import our data. Import data. So in this case we are going to be looking at the salary data, okay, which is in CSV form, right? So we simply create a variable. I'm going to call it dataset. Dataset is equal to, now to read a CSV data, we looked at it last week, we simply use the read underscore CSV function in the pandas library. Okay, so simply call the pandas library pd dot read underscore CSV, and the name of the data enclosed in single or double quotes. So the name is salary underscore data. Okay, so when you're done, then the format .csv. Okay, so we'll run it. So our data has been imported successfully. Now to see the first few rows in our data, we simply use the .head. So we'll call dataset .head. Okay, so we can see that we have two variables in our data, we have the year of experience and the salary. Now the years of experience is simply a independent variable, and the salary is a dependent variable, because for you to earn a huge amount of money in salary, it's also dependent in your years of experience. Does that make sense? Alright, so if you want to get the summary statistics, okay, of your data, so you simply use the describe function. So you call your variable name dataset dot describe. So this will give you the summary statistics of your data. Okay, so you have the number of, the count here signifies the number of rows. We have 30 rows each. The mean years of experience is 5.31, and the mean salary is this. The standard deviation is this for both. The minimum value that for years of experience, which you can see here, is 1.1 year. Okay, that's a year and a month. And the minimum salary is this. This 25% is simply the first quartile. Okay, we are not going to go into the math here. 50% simply signifies the median, and 75% is the third quartile. Then we have the maximum year of experience, which is 10.5 years, and the maximum salary here. Okay, so the next thing we do is we check for missing values. Although this data is quite small, right? So is but we'll still have to check for missing values. So we say data set. To check for missing values, simply use the is null, right? Is null. Then you sum them, dot sum, to get it. So we don't have any missing value in our data, which is quite expected, right? Now the next thing we do is we separate our data into training and testing sets. So sorry, not training and testing set, into dependent and independent variable. So separate our data into dependent and independent. Now, like we already know, the salary here is independent variable, dependent variable, because salary is dependent on the year of experience, isn't it? So our year of experience is independent variable. Our salary is our dependent variable. So we have to separate them. Okay. So what we do is now there is something I didn't teach you, how to index a row. Okay, so I'm going to quickly show you. Okay, it's very easy, like it's as easy as ABC. Now if you want to index everything under years of experience, okay, of course we saw how to index a column by simply using the square brackets, okay, for a single column, or using double square bracket for multiple columns, isn't it? So now I'm going to show you something else. Now, to index our independent variable, we call our variable name data set. Then we use a function called the ilog. Ilog is short for integer location. Okay, so you can get help on ilog by putting a question mark here and running it, so you see what it's all about. So you can see purely integer location based indexing for selecting by position. So if you want to select an item by position, you simply use the integer location. Okay, so let's try to select years of experience based on location. So we simply put dataset.ilog, we use a square bracket. Now let me view my data again so I can be seeing it appropriately. Like say data set dot head. Okay. Alright, now if I want to select everything on the row, I simply, this integer location here takes into argument the rows and the column. Okay, so if I want to select everything on the row, I simply use a full column, then I put a comma here. So the first parameter here denotes the row, and when you put a full column, you are simply saying you want to select everything on the row, on each of these rows. If you put, let's say, full column and you put 10 here, you are simply saying you want to select the first 10 items on the row. Okay, so want to select everything on the row, comma, then we want to select the column except the last one, so we can simply put full column minus 1, just like we did when we looked at indexing and slicing, right? So this we select all the row for us and any other column except this last column here. Okay, so now if for your assignment which you are going to get, okay, the data set, you are going to follow the same method. The last row, the last columns are usually the dependent variable, so you can simply execute this similar command to extract everything except the last column. Okay, so when we run this, we see that we only have the years of experience, right? Now, but like I told you previously, the machine doesn't take in data frames or series. What the machine takes in is arrays. So we simply have to convert this into a NumPy array, and to do that we use the value function. We simply say dot values, okay, and we run. So you can see we now have an array of that column. So we simply assign this to our independent variable, which in this case is x, given our what's it called, formula for regression, which is this, right? Okay, so let's look at the time to make sure. Okay, now we have to be fast. Okay, so we've done this. We simply run it again to store it as x. Sorry, where did this come from? Data set, data set dot ilog. What's happening? Give me a second. Okay, now the next thing we're going to do is to select our dependent variable, which is the salary. So we are going to follow similar method by calling our variable name first, data set, use our integer location. Okay, so how do we get this part? It's very simple. First we recall that ilog takes in two parameters, the rows and the column, right? So we specify that we want all the rows by putting a full column here and put a comma. Then for us to get this last column, we know that Python start counting from 0. So the first column here has position 0 and the second one here has position 1. So we simply put 1 here. Okay, so when we run this, we see that we have the salary. Okay, but this is still in series form, so we convert to array by using the dot values. Okay, so which now worked. So we assign this to our variable y. So we simply say let y be equal to this. Okay, then we run it. All right, so everything is set. Now what we need to do next is we need to split our data into training and testing sets. Just like the teacher teaching the student in class, the teacher taught the student how to identify a fish based on the features. Then in exam or in test, the teacher gives the student a rough sketch of a fish to label, right? So we want to see how our machine is able to learn from this data so as to predict a salary. So what we do is we try to split our data, and to do that we have to import one more library, which in this case is which in this case is our scikit-learn library, okay, sklearn for short. So to do that, we simply say from sklearn, okay. So in this sklearn we have a feature there called model selection. So in model selection we have lots of inbuilt functions that we can leverage on. So we are going to be seeing them as we proceed in this course. So we simply say from sklearn.model underscore selection. Like I told you, you don't need to cram this code, okay? What you just need to do is you identify the patterns that I'm taking. This is similar for all machine learning projects, okay? So you know the patterns, you just have to know that you have to do this, you have to split your data. So in case you don't remember this code, you can just Google how to split data into training and test set in Python. So, and you get this code for it, as simple as that. So you simply say from sklearn.model underscore selection, we want to import train underscore test underscore split, okay. So when you are done with this, you run it. Okay, so let me pause this so don't waste time. Okay, now we've imported the function train test split, so let's see what parameters it takes. Okay, so train, okay, put a question mark in front of it, run. So we can say that this splits arrays or matrix into random train and test subset, okay. So you can go through these are very detailed, you have some examples and they are awesome to look at. So let's quickly do that because of time. So now we have different results from here, okay. We have to declare 4 different variables. The first one we have to declare is the x underscore train, okay, s underscore train. This is going to take our training set for independent variable, because we know we are going to split this. We've already categorized them into dependent and independent variable, right? So this we are going to split it into 2. We call it x train and x test, okay, test. Then we also split this one into 2. We call it y train and y test. So y underscore train, comma, and y underscore test. And we are going to set all this into equal to this train test split. Control C, Control V. So we're going to set it equal to this train test split, and this is going to take some argument. The first one is going to take the independent variable, so we'll put x here, put comma. It's going to take the dependent variable, which is y, put y. Then it's going to take the test size, okay, So okay, it's going to take the test size. So since our data is a very small one, so we are going to set the test size to be 1/3 of our data. So test underscore size, so it's going to be 1/3. Okay, so it's going to assign 1/3 of this data to our test set. So when you are done with this, we simply run it. Awesome. So you can view any of the variable. Now you can decide to print your x underscore train if you want, and you see your array here. Okay, this contains the other part of your data. Now the next thing we have to do is to go on building our model. Okay, so write a comment, building our regression model. Okay, so now we are going to make use of a regression algorithm called linear regression. Okay, so I'm going to give you other examples, other models you can use, like the random forest and the support vector. I'll try to send you the code on our chat platform. Okay, so we have to import our linear model here by simply saying from sklearn. Okay, scikit-learn is a very powerful library in Python which houses machine learning models and different important functions. Okay, so from sklearn we want to get the linear models. Okay, linear model. So from the linear model feature, we want to import the linear regression. So you have to take note that the L here is capital letter and the R is also capital letter. Okay, so when you are done with this, you run it. Okay, so now this imported successfully. So what we need to do next is we assign this function to a variable. We can call the variable regressor. Feel free to call yours anything. So I'm going to call mine regressor. Regressor is equal to I can just copy this, Ctrl C, Ctrl V, so with parentheses. Alright, then I'll run it. Okay, now we are making progress. The next thing we do is to fit our model. Okay, fitting our model. So what do we mean by fitting? Now if you look at this data, fitting is simply for the machine to understand the pattern. The machine will go through this data and say, okay, when the year of experience is this, the salary was this, okay, and when this is this, he identifies the pattern between the year of experience and the salary so as to be able to make prediction for any other different data that was given to it. Okay, so that's what we'll do by fitting the model. Fitting the model in the sense that we want the machine to learn from our data. So, and to do that, we simply use the fit function. So what we'll do is we simply call our variable name regressor, and we'll simply say dot fit function. So what do we want to fit? We want to fit our training independent variable and the training dependent variable. So we'll simply say x underscore train, comma, y underscore train. So let me explain this for you again. So what this fitting does is it looks at this training set and this training set and identifies the similarities between them so as to build a perfect regression model for us. Okay, so when you are done with this, we run it. Okay, so I'm coming. All right, now we have fitted our model. The next thing we do is we make predictions using the test set. Okay, sorry, the test independent variable. So we can call this y underscore predict, y underscore pred. Simply say this is. Now, to make prediction, we simply use the predict function. So we call our regressor dot predict. Okay. So what we want to predict now, we want to make prediction for the salary based on this S test here. So we simply say S underscore test. Okay. Then we run it. Now we've made predictions, but we want to cross-check this predicted value and our test value to see how well our model performed. Okay, so to do that, we have to impute them into a dictionary. So I'm going to create a variable dictionary. Okay, this is going to take in the two keys, actual value, which is our y underscore text. Okay, and it's also going to take the predicted value, which is now our y underscore pred. Okay, so run this. So we've converted to dictionary. Now the next thing we do is we convert this our dictionary to a pandas data frame. Okay, to do that we call it table. We can call it result is equal to pd dot data frame. Okay, pd dot data frame to convert to data frame. So what are we converting? We are converting our dictionary to data frame. So we'll run this. So let's view our result to see result. Beautiful. So you can see that when the salary was supposed to be what's this 64,445, model predicted 56,166, so which is a bit close. This is also a bit close, and this you can see how our machine learning model is able to learn the relationship between the what's it called, the year of experience and the salary, so as to be able to make predictions. So let's make this a bit interesting by visualizing our results. Okay, let's say we want to visualize the first 10 items in our result, or the first 9. Okay, can simply say result dot head. Okay, say I want to dot head 10. Okay, then want to plot it, dot plot. We specify the kind of plot we want. Let's say we want to plot a bar plot, then we'll run. Okay, wait for it. So this is taking a bit. Okay, good. Now you can see how well our model performed. The blue color is the actual value, and this color, this is yellow, right, is the predicted value. You can see that our model performed very well. For instance, you can see some were accurately predicted. Okay, now let's look at our time to make sure we don't overspend. Okay, we still have like 5 minutes. Now you can visualize, you can make a scatter plot for the training set. Okay, so I'm quickly going to do that using matplotlib. So I simply say plt dot scatter. This is a function for plotting a scatter plot. Okay, so want to plot x underscore, want to visualize the training result. Now x underscore train, okay, and y underscore train. Okay, so I want the color to be, want to specify color to be red. So if we run this, let's see what we have. Okay, if we run this, we can see the scatter plot. Now we have to draw a regression line here to capture the line of best fit. Okay, so we simply do a plt.plot, plt.plot. Okay, so this plt.plot is going to take x underscore train. Okay, and the second parameter is going to be the regressor, the predicted value, right? So we can call it regressor dot predict. Okay, so it's going to predict. Now because we are visualizing the training set, so want to predict the x train. Okay, then we can specify the color to be blue. You can choose any other color if you want, blue. So then we'll run this and see. Alright, now this is what we call the line of best fit. Okay, it captures the data points. So you can specify your title by using plt dot title. You can call your title anything. You can say visualizing the training results. Then you can specify your x-axis, s label. You already know how to do that. You can specify your s label and plt dot x label. Our x label is what? Experience. Then our y label, plt dot y label. This is our salary. So when you're done with this, you can just run. Awesome. So you have the title, you have the y-axis and the x-axis. So if we want to visualize the text data, we can just copy this, Ctrl C, paste here, Ctrl V, and we simply change this to test. Okay, then change this to test. Now every other thing remains the same, so we can just run this and we see that this and this are different. So this is okay, visualizing the test results. So all right, we've done a lot, so let's quickly recap with the speed of light. So the first thing we do is we import our libraries. We imported NumPy, Pandas, and Matplotlib, which is used for visualization. Then second step is we read our data. We looked at the first few rows in our data. We looked at the summary statistics using the describe function. We checked for missing values, which fortunately for us, none. Then we separated our variables into dependent and independent variable, right? Using the ilog function. Okay, you can practice more with this. It's very easy and very convenient. So we simply declare the variable x, which takes in the years of experience as our independent variable, then y to take in the dependent variable. Then we started splitting our data by importing the train test split from the model selection in scikit-learn library, okay, which takes in different variables, different arguments, the independent variable, dependent variable, and the test size. Okay, so then we started building our linear regression model by importing linear regression from the linear model in scikit-learn. Then we declared a variable for the linear regression called regressor. Then we fitted our model so that our model will learn from our variables, right? We made predictions on the test set. Okay, we converted our results, the actual value, into dictionary, and the predicted values into dictionary as well. Converted our dictionary to a pandas data frame, then made a plot, and then made the visualize our training and test results. Okay, so this brings us to the end of this week's lecture. Okay, now feel free to ask questions on the platform, okay, because these things are very important and they are very easy to do. Okay, so you'll be getting your assignments, okay, which is going to be a bit how do I put it, your assignment is going to be on multiple linear regression, not simple linear regression, okay, but they are the same, they follow the same process. So please try to subscribe to this YouTube channel if you've not done that already, and we'll meet again on the platform. Okay, until then, enjoy machine learning and stay safe. Bye.